Hello and welcome to this series of briefings for the various exercises to be flown for the UK National Private Pilot's Licence or NPPL and Microlight rating. My name is Martin Jady and I am an instructor with Airborne Aviation at Popham Airfield in the UK, teaching on the Icarus C-42 3-axis Microlight. These are not meant to replace the briefing from your instructor. They should, though, help introduce you to an exercise to help maximise your learning when you fly. They will also serve to refresh previous exercises so you can concentrate on any new elements rather than spending valuable time in the air revising something that you have previously flown. Any performance figures used are generalised around the C-42. Specific figures for your aircraft will be provided when you are briefed by your instructor. If you find these briefings helpful, then it helps me to produce them if you hit like and subscribe. Please share if you think they will be useful to someone else, and please feel free to leave comments. Many thanks in advance. Exercise 12 involves flying the entire circuit, so I have broken it down into parts. This briefing covers just the basic takeoff. You may find that your instructor teaches you the basic takeoff along with earlier exercises so as not to waste the opportunity and to maximise your training. The aim of this briefing is for you to be able to take off and climb out. Let's take a look at the theory. Takeoff distance is typically defined as the distance required from the start of the takeoff roll to clear a 15-metre or 50-foot obstacle. That's about the height of a 4-storey building or a typical mature tree. Distances will be found in your Aircraft Pilot Operator's Handbook. Takeoff and climb performance are affected by the various factors that follow. Firstly, weight. An increase in weight reduces both acceleration and rate of climb. The weight may come from things we can control, such as passengers, baggage, or how much fuel we carry. Or it may come from external factors such as ice, frost or snow on the aircraft. Ice, frost and snow can also disturb the smooth flow of air over the aircraft, particularly the wings, reducing lift and increasing drag and stall speed. The amount of power that the aircraft produces has a direct effect on takeoff performance. The power that the engine develops, and therefore the thrust that the propeller produces, are reduced as air density is lowered. Reduced power and thrust reduce takeoff performance. A little more about air density in a moment. Using flaps. Takeoff flaps are used to lower the speed at which the aircraft becomes airborne and increase the angle of climb. Although there is a slight increase in drag, this is outweighed by the greater increase in lift for most aircraft using one stage of flap. Now, air density. Unless otherwise stated, takeoff performance figures are given for an aircraft taking off in conditions known as the International Standard Atmosphere, or ISA for short, and with nil wind. This is an agreed datum where the density is 1.225 kilograms per cubic metre. When there is no humidity, the temperature is 15 degrees Celsius and there is a pressure of 1013.25 hectopascals. You don't need to remember these figures for the exercise, but they may come in handy for your ground exams. For the time being, though, it's important to know that if air density reduces, then lift, power and thrust are reduced. Any combination of temperature and humidity above the ISA and a decrease in pressure below the ISA due to the weather or altitude will reduce air density and therefore takeoff and climb performance. A quick way to remember is hot, high, humid. Any or all of these reduce air density and takeoff performance. The runway surface and slope have an effect on takeoff as well. Upslopes reduce acceleration. Soft or long grass will reduce acceleration compared to tarmac, and snow or slush on the runway will do the same. Wind speed and direction. Whenever possible, we take off and land into wind. We will look into that a little more in the next section. As you progress through your training, you will learn how to take into account all these factors using tables and formulas to calculate safe takeoff and landing distances. These formulas and tables may be found in the Aircraft Pilot Operator's Handbook, as well as the aircraft's limitations, such as maximum weight, maximum takeoff and crosswind speeds, for example. There is also some very good information on calculating aircraft takeoff and landing performance in the Skyway Code, published by the UK's CAA, which is available for free online. Now, a little more about why we take off into wind whenever possible. Lift is generated by airspeed, the speed at which the air passes over the wing. In the first example, there is no wind, shown by the windsock. To achieve 40 knots airspeed, the aircraft has to accelerate to 40 knots ground speed to generate enough lift to fly. The second aircraft has a 10-knot headwind. Before even moving, there is a 10-knot airspeed generating lift. It only has to accelerate to 30 knots over the ground in order to achieve the 40 knots airspeed required to fly. As you can see, this requires less distance. It also means less wear and tear on the aircraft undercarriage, as it only has to reach 30 knots ground speed before the aircraft lifts off. Finally, the aircraft at the bottom has a 10-knot tailwind. To achieve 40 knots airspeed, it actually has to reach 50 knots on the ground roll. This is more wear and tear on the aircraft, and in some instances, there might not even be enough runway to do this. Taking off into wind also has a positive effect on climb-out performance. The aircraft in the first example is taking off in nil wind. It accelerates to 40 knots airspeed, takes off and climbs away through a block of still air. In the second example, there is a 10-knot headwind. Since the block of air is moving towards the aircraft, its ground speed is only 30 knots as it reaches 40 knots airspeed, takes off and climbs away. Like the aircraft above, it has the same rate of climb, but the distance it travels over the ground is shorter, meaning its angle of climb is greater, giving the aircraft better clearance over obstacles ahead. We'll look at that once more, starting both aircraft together and giving each of them a 15-metre or 50-foot obstacle to clear. Both aircraft take off at 40 knots airspeed, and they take the same amount of time to climb to the same altitude. But the second aircraft, with a headwind, has a shorter ground roll, steeper angle of climb, and better obstacle clearance. Now let's look at the method. Since the runway is a busy and potentially dangerous place, we need to be efficient and minimize the time we spend lining up and taking off. Therefore, we start at the hold, before entering the runway. If there is a hold board, we will confirm that we are at the correct runway and which way to enter. Although we have done it before during our pre-flight vital actions and power checks, we will take this opportunity to check again that we have our flaps and trim set as required and that engine temperatures and pressures are within limits. If we have cowl flaps fitted, we check they are open. If fitted, that the carb heat is off, the landing light is on, and that the transponder is set to alt. We can build situational awareness by listening on the radio for position reports from other aircraft before we even arrive at the hold, but we will make a thorough lookout to ensure that it is safe to enter the runway. If space allows, sometimes at smaller airfields, we might be able to make a lookout turn to check around the circuit for other aircraft. In this example, runway 03 has a left-hand circuit. After completing pre-flight checks, the pilot turns left, scanning around the circuit before taxiing to the hold. Since the aircraft has a high wing, they have also stopped at the hold so that the wing does not obscure the view of final and that they are able to see over their shoulder down the runway. We then make a radio call. Based on the airfield we are at, we may simply need to inform others that we are entering the runway. At larger airfields with air traffic control, we will need clearance to enter the runway and to take off. Note that we only use the words takeoff or taking off when reading back our clearance or starting our ground roll. At all other times, we refer to being ready for and lining up for departure. Do not enter the runway unless you are sure it is safe to do so and you have the required clearance to do so. We want to be efficient and organized about entering the runway. We need to line up on the center line, pointing straight down the runway. Pointing straight means looking straight ahead of yourself to the far end of the runway. If there is a center line, picture it disappearing under the nose and passing under your right foot. There is a temptation to look towards the nose of the aircraft, but as you can see here, it actually means that the aircraft is pointing left. Also line up so that you have as much runway available as possible. There is another short video in this playlist explaining how to do this. The red line here represents my abort point at the hangar, and we will talk a little more about that shortly when we discuss threat and error management. Once straight, we check runway heading against the compass to ensure it is the correct runway. Then, looking towards the far end of the runway, we pick an aiming point. Hold the stick back and apply into-wind aileron if doing a crosswind takeoff. More about crosswind takeoffs in another video, but it is important to start incorporating this consideration so that it becomes a habit. We can now radio that we are taking off. Smoothly apply full power over 3 seconds. As the power comes on, a C-42 wants to yaw left, so steering with our feet, applying right rudder pedal and using our aiming point, we keep ourselves straight. The aircraft will also pitch up, lifting the nose wheel off the ground. As this happens, we release some of the back pressure on the stick so that the nose doesn't rise too much. We want the nose wheel to be just clear of the ground. We now check the RPM gauge to ensure that we have full power and that the airspeed indicator is beginning to register airspeed. Continuing to steer, as the airspeed increases, we can reduce the crosswind aileron and hold enough back pressure to maintain an attitude that keeps the nose wheel just off the ground. When we reach enough airspeed, the aircraft will lift off. As it does so, we need to release just a little more back pressure so that we fly briefly straight and level along the runway. This is flying in ground effect. The rolling resistance of the undercarriage no longer has an effect, and the aerodynamics this close to the ground mean that drag is reduced, allowing the aircraft to accelerate more quickly. We may also need to adjust our heading, turning slightly into wind to prevent a crosswind from causing us to drift off our track to the aiming point. Note the new heading for climb out. As the speed nears the top of the white arc on the ASI, we now reapply some back pressure to the stick to raise the nose. This stops the increase in speed, as we have one stage of flaps set, and causes us to transition into a climb, with the airspeed in the white arc still. During the climb, we check our engine T's and P's, our airspeed, and our heading. At 300 feet above ground level, we remove the flaps and continue to climb out at 65 knots. This gives us a good rate of climb with a 5-knot margin above our glide speed of 60 if we have an engine failure. During climb out, we lower the nose periodically to maintain a good forward lookout. We'll look at that once more, this time as a continuous action. Using all available runway, we line up on the center line, pointing straight, and check the compass against runway heading. Then select an aiming point at the far end of the runway. We hold the stick back and apply into-wind aileron if required. If we have clearance, we radio we are taking off, then smoothly apply full power over 3 seconds. Using our feet, we steer towards our aiming point, releasing some of the back pressure so that the nose wheel is just off the ground, and check we have full power and the airspeed is reading. As we accelerate, we reduce the into-wind aileron. When the aircraft lifts off, we release a little more of the back pressure to fly straight and level and accelerate in ground effect. We turn into wind to compensate for any crosswind to maintain a runway heading. As the airspeed nears the top of the white arc, we apply back pressure to the stick, raising the nose to stop the acceleration and transition into the climb. We check our engine T's and P's, that our airspeed is just in the white arc, and that we are tracking along runway heading. At 300 feet above ground level, we remove flaps and continue to climb away at 65 knots, maintaining a good forward lookout. Let's now talk about airmanship and threat and error management. To begin with, some air law regarding our takeoff. Firstly, aircraft in the air have right of way over aircraft on the ground. We must give way to aircraft on approach, or possibly even on base leg if it is a small circuit. We cannot take off on a runway that is occupied by another aircraft. We may line up for departure whilst another aircraft is taking off or finishing its landing roll, but we must not commence takeoff unless cleared to do so and the runway is clear. Depending on the level of air traffic control at the airfield, we may need permission to taxi, to enter and line up on the runway, and to take off. Ensure that you understand the rules and procedures that apply to the airfield you are operating from, so that you can request the required clearances. If unsure, speak to someone in ops before going out to your aircraft. Threats. As ever, one of the greatest threats to us is other aircraft, and we must build situational awareness by both looking out and listening on the radio throughout. This is especially for aircraft on final before we enter the runway. Wake turbulence. Aircraft disturb the air as they pass through it, creating vortices. The larger the aircraft, the larger the vortices. This disturbed air is invisible and can easily upset a microlight in flight. If an aircraft, particularly a heavier one, has just landed or taken off, then allow time for these vortices to dissipate before commencing takeoff. During takeoff, a threat we must always be prepared for is engine failure. This threat we mitigate by planning emergency actions during our pre-flight checks. We should regularly practice the actions to be taken at different stages if the engine should fail. Using all the available runway gives you the most options. Firstly, select an abort point, as you saw earlier. This is the point at which we still have enough room to stop on the runway if we don't have full power, the ASI isn't registering, or anything seems unusual. If the engine were to fail immediately upon liftoff or very shortly after, we will land back onto the runway if possible. If we have an engine failure after takeoff and at any point during climb out, then we will look for somewhere to land 30 degrees either side of straight ahead, preferably into wind. If we are operating from an airfield we know, we might well have decided already directions or even fields to look for in the event of an emergency. The higher we are, the more options we have, but the more we maneuver, the more height we lose. We never turn back to the airfield. The temptation is great, but the risk of stalling and spinning whilst trying to make a 180-degree turn during the pressure of an engine failure is far greater. Finally, maintaining flying speed is essential. We remind ourselves of the speed we need and that we will need to pitch down to achieve that speed. Workload is another threat, particularly if we are departing from somewhere we are unfamiliar with. Prior to engine start, have a clear plan to take you from taxi, takeoff and climb out to being en route on your first leg. That might be on a cross-country or just to the downwind leg for circuits. Workload can also be particularly high if it is your first flight in a while or even just of the day. What the winds are actually doing is still unknown. You haven't flown for a while, so you are rusty. To help mitigate these threats, don't rush. Be methodical, plan and refresh yourself with aircraft performance, airfield procedures and all your emergency drills. Errors that can occur during taxi and takeoff include not having or understanding the required permissions and clearances. Study the requirements and rules of the airfield you are operating at. If it is new to you and it's possible, then pop into ops and ask about their procedures. Listen carefully on the radio and write things down on your kneeboard. The wrong runway. It does happen. Plan your taxi using airfield plates or SkyDemon before engine start, and if in doubt, ask for help on the radio. Runway incursion. This is where you enter a runway in use without clearance, or whilst another aircraft, such as one on final, has right of way. We trap this error with planning and building situational awareness through lookout and listening on the radio. If in doubt about entering a runway, then don't. Stop, and if available, ask for help on the radio. Altimeter setting. Typically, QFE is used for height for circuits, and QNH is used for altitude for local and cross-country flights. Methodical planning and use of checklists and drills should ensure that your altimeter is set correctly for the airspace you are in and the flight you wish to conduct. The Skyway Code, mentioned earlier, also has a very good section on altimeter setting. At this point, your instructor will usually summarize what you will be doing, with current details regarding the weather, the airfield and training area, NOTAMs and any other necessary information. Then finally, there is an opportunity for your instructor to check your understanding with a question or two, and for you to query anything that's not clear. I will leave you with this final image summarizing the briefing. I hope you found it useful. If you have, then I'd be grateful if you click like and subscribe. Feel free to leave me comments, and if you think anyone else would benefit from watching, then please share. Until the next time, wishing you fun and safe flying.